Imagine stepping outside tonight, looking up, and seeing something impossible. A massive, shimmering spacecraft hovering silently over the heart of a major city, like Westminster in London. No lights, no sound, just an eerie presence that defies everything we know about physics. Now picture NASA's live stream, broadcasting from a deep space telescope, suddenly cutting out. Renowned physicist Brian Cox appears on air, his voice steady but urgent. What we're witnessing may force us to rewrite everything we thought we knew about deep space. This isn't science fiction. This the story of Oumuamua, an object that's turned the scientific world upside down and left us questioning our place in the cosmos. Stick with us for the next 20 minutes, because this mind-blowing mystery might just change how you see the universe. Hit that subscribe button, and let's dive into the most controversial astronomical event of our time. It began as a routine sky survey on April 7th, 2025, when a deep space telescope over the Pacific Ocean, operated by NASA's Jet Propulsion Laboratory, detected something extraordinary. An object, unlike anything we've cataloged, appeared in the telescope's field of view. It wasn't a comet, an asteroid, or a distant star. It was something else entirely. Named Oumuamua, this object didn't just pass through our solar system like its predecessor, the 2017 interstellar visitor, Oumuamua. It slowed down, changed direction, and then stopped, hovering in a geosynchronous orbit above Earth's magnetic equator. Within minutes of the sighting, NASA's live feed went dark. The raw footage was deleted, and official statements claimed a system-wide failure. But the truth couldn't be contained. Independent observatories in Chile, South Africa, and Australia confirmed the sighting, and the data they captured sent shockwaves through the scientific community. If this kind of cosmic mystery excites you, make sure to like this video and share your thoughts in the comments below. Are we on the brink of a scientific revolution, or is something bigger at play? Let's unpack what makes Oumuamua so extraordinary and why it's sparking debates among the world's top scientists. At first glance, Oumuamua bore a striking resemblance to Oumuamua, the cigar-shaped interstellar object that passed through our solar system in 2017. That earlier visitor baffled astronomers with its unusual shape, reflective surface, and non-gravitational acceleration, leading Harvard astrophysicist Avi Loeb to propose it might be an artificial probe. But Oumuamua left before we could study it closely. Oumuamua, however, didn't leave. It lingered, and its behavior defies every known law of physics. Unlike any natural object, Oumuamua exhibited non-ballistic motion, meaning it moved in ways that gravity alone can't explain. It decelerated as it approached Earth, with no visible propulsion system. NASA's Deep Space Network detected micro-vibrations from the object, consistent with internal guidance mechanisms, as if it were actively steering itself. Thermal imaging revealed localized fluctuations around its structure, suggesting some form of active regulation, like cooling or shielding. Most chillingly, just before NASA's feed cut out, the object emitted a beam of prime number pulses aimed directly at Earth's upper magnetosphere. Prime numbers 2, 3, 5, 7, and so on are considered a universal language, a hallmark of intelligent design. This wasn't a random cosmic event, it was a signal. Brian Cox, speaking on a BBC broadcast shortly after the incident, described it as the most significant astronomical event in modern history. He speculated that Oumuamua could be a cosmic tripwire, a sensor left in dormant orbit, waiting for a civilization advanced enough to detect it. This idea ties into the Fermi paradox, the question that haunts astronomers. If the universe is teeming with life, where is everyone? Perhaps the silence isn't an absence, but a deliberate choice. maybe we've just tripped the wire. If you're as fascinated by this as we are, hit that notification bell so you don't miss our weekly deep dives into discoveries like this. But before we go further, let's take a quick break to talk about something grounded right here on Earth. Life on Earth can be unpredictable, just like the cosmos. If you've ever been in an accident, you know how insurance companies can try to lowball you, offering settlements that don't come close to what you deserve. That's where Morgan & Morgan, America's largest injury law firm, steps in. They've secured life-changing settlements, like $12 million in Florida and $26 million in Philadelphia, often 30 to 40 times more than initial insurance offers. Best of all, there are no upfront fees. You only pay if they win your case. Their process is modern and seamless. You can submit a claim and communicate with your legal team right from your smartphone. If you've been seriously injured, your case could be worth millions. Start your claim today at www.forthepeople.com/specialize or scan the QR code in the description below. Now, let's return to the stars. After Oumuamua's appearance, independent observatories reported a directed burst of electromagnetic radiation in the X-band, structured in prime number intervals. This wasn't just noise. It matched a fragment of the Voyager golden record, specifically the sound of a human heartbeat. One pulse, then 3, then 5, then silence. The Voyager golden record, launched in 1977, was humanity's message to the cosmos, a snapshot of our existence. For an object to echo it back feels like a mirror held up to our species, a message that says, "We see you." But the real shock came from an unexpected source. Voyager 1, humanity's farthest spacecraft, drifting 43 light-hours away in interstellar space. On April 7, 2025, at precisely the same moment, CERN's magnetometer array detected a global magnetic distortion lasting 0.72 seconds. Voyager 1 transmitted a signal it wasn't designed to send. The signal matched Earth's event to the millisecond, containing data that NASA engineers confirmed was not part of Voyager's programming. It was as if the spacecraft had been hijacked, used as an interstellar relay to send a custom-encoded message. The data, partially decoded by a Finnish radio astronomy team before their access was cut off, revealed a mathematically elegant structure: nested prime intervals, logarithmic spirals, and binary wavelets. This wasn't random noise. It was a framework, like a cosmic zip file locked with a key we don't yet possess. What makes this even more unsettling is the silence that followed. NASA pulled the data from public logs within hours. Researchers reported revoked credentials, and a leaked memo from the Jet Propulsion Laboratory classified Oumuamua's flight path. This isn't standard protocol, even for sensitive military projects. Something about this object is different, and the powers that be don't want us looking too closely. Let's consider the implications. If Oumuamua triggered a magnetic pulse on Earth and a simultaneous reply via Voyager 1, we're not dealing with a single object. This could be part of a distributed network, a silent surveillance system embedded across our solar system. Dormant probes, disguised as comets or asteroids, might have been watching us for centuries, waiting for a signal to activate. The 1973 Soviet Venera probe's mysterious magnetic whine, the 1989 Galileo spacecraft's anomalous asteroid readings, the 2003 Cassini mission's brief polar inversion in Saturn's magnetosphere. These dismissed anomalies now look like breadcrumbs. Were they tests, activations, or simply glitches in a system we weren't ready to understand? Brian Cox has suggested a chilling possibility. Oumuamua might be a node in a cosmic filtration system, designed to detect civilizations as they become spacefaring and assess their threat level. This aligns with the Great Filter theory, which posits that advanced civilizations face a barrier that few survive. What if the filter isn't behind us, but right in front of us? What if our technological advancements, our telescopes, our probes, our signals into space, have just triggered the system's attention? Cox likened it to a quantum observer effect on a civilizational scale. By noticing Oumuamua, we may have collapsed our own probability wave, forcing the universe to decide our fate. If this is true, the silence we've assumed in the cosmos isn't empty, it's expectant. We're not alone, and we never were. The question isn't whether we'll make contact, but whether we'll survive it. Share your thoughts in the comments. Is this a cosmic test, or are we reading too much into the data? Let's keep exploring. Let's go deeper. What if Oumuamua isn't just a probe, but a judgment system? Imagine a universe where advanced civilizations don't broadcast their 25-year-old Oumuamua, detected by a telescope in Hawaii, sparked heated debates when Harvard's Avi Loeb suggested it could be an alien probe due to its odd shape, reflectivity, and unexplained acceleration. Oumuamua takes these mysteries to a new level. Unlike Oumuamua, which passed through our solar system and left, Oumuamua stayed, positioning itself in a geosynchronous orbit above Earth's magnetic equator, an orbit no natural object should sustain. Its behavior, decelerating without visible propulsion, emitting prime number pulses, and triggering global magnetic distortions, suggests intent, purpose, and technology far beyond our own. What if this object is a cosmic camera, silently measuring our readiness for inclusion in a larger galactic community? Or worse, what if it's a security system designed not to greet us but to evaluate us? The idea that we've been observed all along, not out of curiosity, but as part of a probationary system, flips our assumptions about alien contact. We imagined first contact as a moment of mutual discovery, like two explorers meeting in uncharted lands. But what if we're the ones being discovered, and the judgment has already begun? Since Oumuamua's appearance, the scientific community has grown unusually silent. Several prominent researchers have withdrawn from public appearances. A Princeton physicist who analyzed the object's thermal readings is on an unexplained sabbatical. A Caltech data team took their servers offline for restructuring. Even SETI, the search for extraterrestrial intelligence, has remained conspicuously quiet, their latest updates focusing on mundane telescope calibrations. This isn't the chaotic open debate science thrives on. It's a managed silence. Amateur astronomers attempting to track Oumuamua reported signal distortions, positional drift, and equipment failures. Archived footage from private telescope networks shows flickering interference patterns, consistent with high-energy electromagnetic bursts in low Earth orbit. Yet NASA's official channels mention no anomalies. A leaked JPL memo classified the object's flight path, a move unprecedented for a non-military object. The sky looks the same, but the silence feels heavier, as if the universe is holding its breath. We don't know what Oumuamua is, what it wants, or what it means. The signal it sent, echoed by Voyager 1, could be a greeting, a warning, or something we can't yet comprehend. CERN's final milliseconds of magnetic pulse data remain unreleased, but whispers suggest they contain harmonics that defy terrestrial explanation. Atmospheric monitoring stations in Brazil, Ghana, and Indonesia have detected periodic pressure anomalies aligned with the object's orbit, subtle disruptions with no known cause, as if something is moving between orbit and atmosphere, then retreating. Brian Cox's final warning lingers. We assumed discovery would be mutual, but we've been noticed first. The question now is not whether we make contact, but whether we survive it. This isn't the joyful first contact we imagined. It's a probationary encounter, a moment where our place in the cosmos is being weighed. Are we a threat, a curiosity, or something to be ignored? The dominoes are falling, and the silence is no longer empty, it's expectant. This discovery challenges everything we thought we knew. It forces us to confront the possibility that we're part of a larger system, one that's been watching us for millennia. The anomalies we dismissed, the 1973 Venera probe, the 1989 Galileo readings, the 2003 Cassini inversion, may be pieces of a puzzle we're only now beginning to see. Oumuamua could be the key, or it could be the lock, sealing our fate in ways we can't predict. If this story has changed how you see the universe, you won't want to miss what's next. Subscribe, turn on notifications, and join us as we explore the latest data, theories, and possibilities. Share your theories in the comments. Is Oumuamua a probe, a sensor, or something else entirely? Are we being tested, or have we already failed? The sky hasn't changed, but our perspective has. Let's keep looking up, together. What if Oumuamua isn't alone? The synchronized signals, Earth's magnetic pulse, Voyager 1's impossible transmission, and the prime number bursts suggest a coordinated system far more complex than a single object. Astronomers are now quietly revisiting decades of unexplained data, from fleeting radar anomalies in the 1960s to unexplained energy spikes detected by the Hubble Space Telescope in the 1990s. Could these be traces of a hidden network, a lattice of dormant probes woven into the fabric of our solar system? Some theorists propose that Oumuamua is merely one node in a vast interstellar grid, designed to activate when a civilization reaches a certain technological threshold. If this is true, our every move, every satellite we launch, every signal we send, might be feeding data to an intelligence that's been watching since before humanity existed. Drop your thoughts in the comments. Could our solar system be a cosmic observatory, and are we the ones under the microscope? The emergence of Oumuamua raises questions not just about science, but about our responsibility as a species. If this object is indeed a probe or sensor, what does it mean to interact with it? Should we attempt to send a signal back, risking further activation of an unknown system? Or should we stay silent, hoping to avoid drawing more attention? Brian Cox hinted at this dilemma in a recent interview, suggesting that our curiosity could be our greatest strength or our fatal flaw. The Fermi paradox looms large here. If advanced civilizations exist, their silence might be a strategy, a way to avoid triggering systems like the one Oumuamua represents. By detecting it, have we already crossed a line? This isn't just about science, it's about survival. If you're grappling with these questions, hit that like button and share this video with someone who loves a good cosmic mystery. Let's spark a conversation about what humanity should do next. Perhaps the most unsettling aspect of this event is the silence from those who should be shouting from the rooftops. NASA's lack of transparency, the sudden withdrawal of key researchers, and the absence of SETI's usual enthusiasm, it all points to a coordinated effort to control the narrative. But why? Independent observatories have reported faint, recurring signals in the X-band, aligning with Oumuamua's orbit, yet official channels remain mute. Some speculate that governments are preparing for a larger revelation, one that could redefine humanity's place in the universe. Others fear the silence is protective, shielding us from a truth we're not ready to face. As Brian Cox warned, the universe doesn't owe us an explanation, but it's watching. If this story has you questioning what's out there, subscribe and join us as we dig deeper into the data. What do you think the silence means? Let us know in the comments, and let's keep searching for the truth together. These paragraphs extend the narrative by exploring the possibility of a larger network, the ethical implications of our actions, and the eerie silence from official sources, all while maintaining viewer engagement through calls to action and thought-provoking questions. What if Oumuamua's actions are part of a larger strategic maneuver, a move in a cosmic chess game where humanity is an unwitting player? The object's precise deceleration and geosynchronous orbit suggest a level of control that implies intent, not chance. Some astrophysicists, speaking off the record, propose that its prime number pulses and synchronize signals with Voyager and could be a test of our ability to recognize and respond to non-human intelligence. If so, our next move matters. A wrong signal, or no signal at all, could alter the trajectory of this encounter. The chilling possibility is that Oumuamua isn't just observing us, it's waiting for us to demonstrate our worth, not as scientists, but as a civilization. Are we ready to play a game where the rules are unknown and the stakes could be our survival? Delving deeper into the science, the magnetic distortion detected by CERN on April 7, 2025, hints at a connection to quantum mechanics that defies conventional understanding. The 0.72-second pulse contained embedded harmonics that resemble quantum error correction patterns used in cutting-edge computing systems. This raises a staggering question. Could Oumuamua be interacting with Earth's magnetic field at a quantum level, manipulating probabilities in ways we're only beginning to explore? Brian Cox's reference to a quantum observer effect takes on new weight here. If the object is altering our environment simply by being observed, it might be rewriting the rules of reality itself. This isn't just an astronomical event. It's a glimpse into a universe where consciousness and technology blur, challenging us to rethink what we believe is possible. Oumuamua's presence forces us to confront a profound truth. We may be seeing ourselves reflected in its actions. The object's echo of the Voyager Golden Record's heartbeat feels personal, as if it's speaking directly